What if the future of humanity isn't just on Earth, but scattered across the cosmos, thriving in cities built by machines that don't just assist us, they lead the way? This isn't a distant dream anymore. Right now, organizations like NASA and private pioneers like SpaceX are laying the groundwork for lunar bases and Martian colonies, with artificial intelligence and robotics at the helm. Think about it, these aren't just tools, they're the architects, engineers, and builders of our extraterrestrial future. But how exactly will AI-powered systems design habitats that can sustain life millions of miles from home? What will it take for robots to construct entire cities in the vacuum of space? And most importantly, what does this mean for the survival and expansion of humanity? In this video, we'll explore the groundbreaking technologies, the challenges we'll face, and the incredible possibilities of pioneering space colonies. This is the next frontier, and it's closer than you think. When we think about the challenges of space colonization, one thing becomes clear: the human mind, while brilliant, can only process so much information at once. That's where artificial intelligence steps in, acting as the brain behind the brawn of space exploration. AI doesn't just assist, it enables machines to think, adapt, and solve problems autonomously, even in environments where human intervention is limited or impossible. Take, for example, the way AI algorithms analyze the mountains of data collected during space missions. These algorithms sift through everything from atmospheric readings to geological samples, identifying patterns and making predictions that would take humans years to compute. On distant planets or moons, where conditions are unpredictable, AI systems can forecast environmental changes, helping us prepare for everything from dust storms to radiation spikes. This predictive power isn't just a luxury, it's a necessity for survival in the void of space. One of the most impressive examples of AI in action is NAS, autonomous rovers. These machines navigate alien terrains with no direct human control, using AI to make real-time decisions about where to go, what to study, and how to avoid hazards. Imagine a rover on Mars, analyzing a rock formation and deciding on the spot whether it's worth collecting a sample. This level of autonomy is only possible because AI can process data, learn from it, and act independently. But AI's role doesn't stop at exploration. In the context of space colonies, it becomes the backbone of essential systems. Life support systems, for instance, rely on AI to monitor oxygen levels, temperature, and waste management, ensuring the colony remains habitable. Energy grids in space will need to be highly efficient, balancing power consumption across habitats, research labs, and communication hubs. AI can optimize these systems, predicting energy needs and redistributing resources in real time. And let's not forget communication. AI will manage the complex networks that keep colonists connected to each other and to Earth, even across vast distances. As we look to the future, it's clear that AI is more than just a tool, it's a partner in our journey to the stars. But to bring these systems to life, we need more than just intelligence. We need a physical presence, something capable of building, maintaining, and interacting with the world around it. And that's where robotics comes into play. When we think about the challenges of building colonies on the Moon or Mars, one thing becomes clear: humans can't do it alone. That's where robotics steps in, not just as tools, but as essential partners in the grand endeavor of space colonization. Robots are designed to thrive in environments where humans simply can't. Picture this: a vacuum where there's no air to breathe, temperatures that swing from scorching heat to freezing cold, and radiation levels that would overwhelm our bodies. These are the kinds of extreme conditions robots are built to endure, making them the perfect workforce for the cosmos. Take construction robots, for example. These machines are being developed to 3D print habitats using materials found right on the Moon or Mars. Imagine a robot armed with advanced 3D printing technology, using lunar soil, known as regolith, to build sturdy structures layer by layer. This isn't science fiction. It's a real-world solution that could drastically reduce the need to transport heavy building materials from Earth. By leveraging local resources, we're not just saving time and money, we're paving the way for sustainable living in space. But construction is only the beginning. Once a colony is up and running, maintenance becomes critical. That's where autonomous repair robots come into play. These machines are equipped with sensors, cameras, and AI-driven algorithms that allow them to detect damage, assess the situation, and fix problems without human intervention. Think about the International Space Station, where even small malfunctions can pose serious risks. Now imagine a fleet of robots patrolling a lunar base, ensuring everything from life support systems to power grids stays operational. It's not just about efficiency, it's about survival. Innovations from companies like Boston Dynamics are pushing the boundaries of what's possible. Their robots, known for their agility and adaptability, are being reimagined for space exploration. Whether it's a quadrupedal robot navigating rugged terrain or a humanoid robot performing delicate repairs, these machines are proving that they're more than just tools, they're collaborators. And collaboration is key. As we venture deeper into space, the relationship between humans and robots will evolve into a seamless partnership, where each complements the other's strengths and compensates for their limitations. The future of space colonization hinges on a powerful partnership between humans and robots, where each plays to their strengths. Robots, with their precision and resilience, are perfectly suited for tasks that are too dangerous, repetitive, or physically demanding for humans. Imagine a team of robotic miners extracting precious metals from asteroids or assembling massive space habitats piece by piece. These tireless machines can operate in extreme conditions, whether it's the vacuum of space, scorching heat, or freezing cold, without the need for life support or rest. This frees up human astronauts to focus on what they do best: strategic decision-making, creative problem-solving, and adapting to unexpected challenges. But how do we bridge the gap between human ingenuity and robotic efficiency? The answer lies in advanced interfaces that make collaboration intuitive and seamless. Picture an astronaut wearing augmented reality glasses, seeing through the eyes of a robot as they guide it to repair a critical system on a distant space station. Or consider a control panel that responds to gestures, allowing humans to direct robotic swarms with a wave of their hand. Projects like NASA Robonaut are already paving the way, developing humanoid robots that can mimic human movements and even perform intricate tasks with dexterity. These robots aren't just tools, they're teammates designed to work alongside humans in ways that feel natural and effortless. However, this collaboration isn't without its challenges. Ensuring that robots and humans can communicate effectively in the harsh and unpredictable environment of space requires cutting-edge technology and meticulous planning. A single miscommunication or delay in response could mean the difference between success and disaster. Engineers and scientists are working tirelessly to create systems that are not only efficient but also fail-safe, with redundancies and protocols to prevent errors. The goal is to build a partnership where humans and robots complement each other perfectly, creating a synergy that pushes the boundaries of what's possible in space exploration. As we look to the stars, it's clear that the future of space colonization isn't just about sending humans or robots, it's about sending both, working together as one cohesive team. This collaboration will unlock new possibilities, from constructing sustainable habitats on Mars to mining resources that could fuel humanity's journey deeper into the cosmos. The challenges are immense, but so are the rewards, and with each step forward, we're not just building the next frontier, we're redefining what it means to explore it. While the idea of AI and robotics building space colonies is thrilling, it's not without its hurdles. One of the biggest challenges lies in the limitations of current AI systems. These systems are trained on data collected here on Earth, but space is an entirely different beast. The unpredictable environments ranging from extreme temperatures to low gravity require AI to adapt in ways it hasn't been programmed for. Imagine sending a robot to Mars, only for it to struggle with a terrain or weather pattern it's never encountered before. Without the ability to learn and adjust on the fly, even the most advanced AI could falter. Then there's the issue of hardware durability. Space is unforgiving, and robots face constant threats like radiation and mechanical stress. A single malfunction in a critical component could jeopardize an entire mission. For instance, the radiation levels on the Moon or Mars are far higher than on Earth, and without proper shielding, electronic systems can degrade quickly. Engineers are constantly working to design more resilient materials, but the challenge of creating machines that can withstand years of harsh conditions remains a significant barrier. But it's not just technical challenges we need to worry about, there are ethical questions too. How much autonomy should we give robots in life or death situations? Relying too heavily on AI for critical decisions raises concerns about accountability. If something goes wrong, who is responsible? These aren't just hypotheticals, they're real dilemmas that space agencies and private companies are grappling with as they plan future missions. Thankfully, innovation is rising to meet these challenges. Researchers are developing AI systems that can learn and adapt in real time, even in unfamiliar environments. New materials are being tested to create robots that can endure the rigors of space, and ethical frameworks are being discussed to ensure that as we push the boundaries of technology, we're also safeguarding the values that guide us. The road ahead is complex, but with each breakthrough, we're one step closer to making space colonization a reality. As we venture deeper into the challenges of space colonization, the role of innovation becomes impossible to ignore. Scientists and engineers are tackling these obstacles head-on, creating groundbreaking solutions that push the boundaries of what's possible. One of the most exciting advancements is the development of self-healing materials for robots. Imagine a robotic arm on a distant moon, repairing its own cracks or dents caused by harsh environmental conditions. These materials, infused with polymers or embedded microcapsules, allow robots to autonomously mend themselves, ensuring they remain operational even in the most unforgiving environments. This isn't science fiction, it's a reality being tested in labs and already showing immense promise for future missions. But robots aren't the only ones getting smarter. Artificial intelligence systems are undergoing a revolution of their own, particularly in their ability to learn from limited data. In space, where communication delays and sparse resources are the norm, traditional AI models that rely on vast amounts of information simply won't cut it. Enter AI systems that can make decisions based on small datasets, mimicking human intuition. These systems are being trained to adapt to unexpected scenarios, like navigating uncharted terrain or identifying potential hazards, all without constant human oversight. This leap in AI capability is not just a win for space exploration, it's a game changer for how we approach problem solving in extreme environments. And then there's quantum computing, a technology that's poised to redefine speed and efficiency in space missions. Traditional computers, while powerful, face limitations when it comes to processing complex calculations quickly. Quantum computers, on the other hand, can perform multiple computations simultaneously, offering solutions to problems that would take conventional systems years to solve. Think about mapping the surface of an asteroid in real time or optimizing the trajectory of a spacecraft to avoid collisions. These are the kinds of challenges quantum computing is being developed to address, and its potential applications in space colonization are nothing short of revolutionary. Real-world projects are already putting these innovations to the test. The European Space Agency, for instance, has been conducting trials with autonomous rovers designed to explore the Moon and Mars. These rovers are equipped with AI systems that enable them to navigate rocky landscapes, avoid obstacles, and even make decisions about where to collect samples, all without human intervention. Meanwhile, NASA is experimenting with AI-powered habitat prototypes that can monitor and adjust environmental conditions, ensuring astronauts have a safe and sustainable living space. These projects aren't just theoretical, they're laying the groundwork for the next era of space exploration. What ties all these advancements together is their role in building sustainable space colonies. From self-healing robots that reduce the need for costly repairs to AI systems that ensure efficient resource management, these innovations are creating a blueprint for long-term survival beyond Earth. They're not just solving problems, they're redefining what's possible, paving the way for a future where humanity can thrive among the stars. Sustainability is the backbone of any long-term space colony, and artificial intelligence and robotics are the tools that make it possible. Picture this, a colony on Mars, completely isolated from Earth, where every drop of water and every watt of energy must be carefully managed. AI steps in as the ultimate efficiency expert, analyzing data in real time to optimize how resources are used. For instance, AI systems can monitor water consumption, identifying opportunities to recycle and reuse it in ways that minimize waste. This isn't just about survival, it's about creating a self-sustaining ecosystem where every resource is maximized. Robotic systems play an equally critical role. Imagine autonomous machines patrolling the colony, checking air quality, temperature, and soil conditions to ensure everything stays within the ideal range for human life. These robots aren't just passive observers, they're active participants in maintaining the delicate balance of the habitat. Take the Mars Oxygen In Situ Resource Utilization Experiment, or MOXIE, for example. This groundbreaking device, tested on the Perseverance rover, converts carbon dioxide from the Martian atmosphere into breathable oxygen. It's a glimpse into how future colonies could produce their own air, reducing reliance on Earth for essential supplies. But sustainability isn't just about survival, it's also about efficiency and cost effectiveness. Every resource saved or generated locally reduces the astronomical expenses of transporting materials from Earth. This brings us to the economic side of space colonization, where the stakes are as high as the costs. The ability to harness local resources, powered by AI and robotics, could make the difference between a financially viable colony and one that's too expensive to sustain. As we look to the stars, these technologies aren't just tools, they're the foundation of a future where humanity thrives beyond our planet. Building space colonies isn't just a technological challenge, it's an economic one. The sheer scale of such a project requires massive investments, but here's where AI and robotics step in to make the impossible financially feasible. Take autonomous mining robots, for example. These advanced machines could revolutionize how we gather resources by extracting valuable materials from asteroids. Instead of relying on Earth-based supplies, which are costly to transport into space, we could tap into the vast reserves of metals and minerals floating in our solar system. This not only reduces costs, but also opens up entirely new avenues for sustainability in space exploration. But the economic benefits don't stop there. AI plays a critical role in optimizing the logistics of space missions. From managing supply chains to predicting resource needs, AI can streamline operations in ways that were unimaginable just a few decades ago. Imagine a self-organizing network of AI systems coordinating everything from fuel usage to construction schedules, ensuring that every mission is as efficient as possible. This level of precision cuts down on waste and maximizes the return on investment, making space colonization a more realistic goal. Then there's the potential for space-based industries. Microgravity environments offer unique opportunities for manufacturing products that are difficult or impossible to create on Earth. Think about pharmaceuticals, advanced materials, or even high-precision electronics, all of which could be produced more effectively in space. Robotics will be at the heart of these ventures, handling delicate tasks and maintaining operations in environments too harsh for humans. This isn't just about exploration, it's about creating a new economic frontier that could reshape industries back on Earth. As we consider the economic possibilities, it's impossible to ignore the broader societal implications. Space colonization could shift how we think about resources, labor, and even global economies. It raises questions about who benefits from these advancements and how we ensure equitable access to the opportunities they bring. The interplay between technology, economics, and society will define the future of space, and it's a future that's closer than we might think. Living in space isn't just about building habitats and growing food. It's about creating a society that can thrive in the most isolated and extreme environments imaginable. When we establish colonies on the Moon, Mars, or beyond, we'll need entirely new social structures and cultural norms to keep communities functioning smoothly. This is where artificial intelligence steps in as a critical tool for governance and conflict resolution. Imagine a small, self-contained colony where resources are limited and every decision impacts the group's survival. AI systems could analyze data, predict potential conflicts, and suggest solutions that balance fairness and efficiency. These systems wouldn't just enforce rules, they'd help foster collaboration and trust among colonists, ensuring that everyone feels heard and valued. But beyond governance, there's the human element, the psychological challenges of living in space. Isolation, confinement, and the sheer distance from Earth can take a toll on mental health. This is where robotics comes into play. Robots designed as companions could provide emotional support, engaging in conversations, playing games, or even offering reminders to take breaks and connect with others. They're not just tools, they're lifelines for mental well-being. Projects like the HIC's Mars simulation have already given us a glimpse into how humans behave in confined, high-stress environments. Participants in these simulations have shown that even small conflicts can escalate quickly without proper support systems in place. These insights are invaluable as we prepare for the realities of life in space. As we look to the future, education and research will play a pivotal role in shaping space colonies. Colonists will need to be skilled in a wide range of disciplines, from engineering and agriculture to psychology and medicine. Ongoing research will help us refine the tools and systems we develop, ensuring that life in space is not just survivable, but sustainable and fulfilling. By combining the strengths of AI, robotics, and human ingenuity, we can create a society that thrives among the stars. Imagine stepping into a classroom where the lessons are tailored precisely to your strengths, interests, and pace of learning. In space colonies, this vision becomes reality thanks to AI-powered educational platforms. These systems adapt to each colonist's unique needs, ensuring that whether you're a child learning the basics of physics or an adult mastering advanced engineering concepts, the experience feels personal and effective. This isn't just about convenience, it's about creating a society where everyone has the tools to thrive, no matter their background or skill level. The ability to learn and grow becomes a cornerstone of life in space, fostering a culture of continuous innovation and collaboration. But education is only part of the story. Space colonies will also serve as epicenters for groundbreaking scientific research. Picture robotic laboratories, tirelessly working to unlock the mysteries of the universe. In the field of astrobiology, these labs could analyze soil samples from distant planets, searching for signs of life or clues about the origins of life itself. In materials science, they might develop new alloys and compounds that can withstand the extreme conditions of space, paving the way for stronger, lighter structures. And in medicine, experiments conducted in microgravity could lead to breakthroughs in understanding human health, potentially revolutionizing treatments for diseases that have plagued us for centuries. The importance of training the next generation of space explorers and engineers cannot be overstated. These pioneers will need to be adept not only in traditional STEM fields, but also in working alongside AI and robotics. Hands-on experience with cutting-edge technology will be essential, preparing them to tackle the challenges of building and maintaining life sustaining habitats on other worlds. It's a multidisciplinary approach that blends science, creativity, and practical skills, ensuring that humanity's future in space is not only possible, but also prosperous. As we look ahead, the role of AI and robotics extends beyond education and research. They will be instrumental in shaping the very environments we inhabit. Terraforming, the process of transforming inhospitable planets into Earth-like havens, is one of the most ambitious goals of space colonization. AI systems could analyze planetary data to determine the most effective strategies for altering atmospheres, while robots could carry out the physical work, from seeding plant life to constructing infrastructure. Together, these technologies have the potential to turn barren worlds into thriving ecosystems, opening up new frontiers for exploration and settlement. The journey to creating space colonies is not just about survival, it's about redefining what's possible for humanity. Imagine a barren, lifeless world, a cold, desolate landscape where no human could survive without advanced technology. Now, picture that same world transformed into a thriving ecosystem, complete with breathable air, flowing water, and lush greenery. This is the ambitious goal of terraforming, and it's not just science fiction anymore. With the help of artificial intelligence and robotics, humanity is inching closer to turning this dream into reality. But how exactly do we achieve such a monumental task? The answer lies in the synergy between cutting-edge technology and human ingenuity. Artificial intelligence plays a pivotal role in the early stages of terraforming by simulating potential strategies and predicting their outcomes. For instance, AI models can analyze vast amounts of data to determine the most effective ways to warm a planet. One approach might involve releasing greenhouse gases into the atmosphere, mimicking the natural processes that keep Earth warm. Another strategy could focus on creating artificial magnetic fields to protect a planet from harmful solar radiation. These simulations allow scientists to test countless scenarios without risking resources or time, ensuring that the best possible plan is chosen before any physical work begins. But simulations alone aren't enough. That's where robotics come in. Once a terraforming strategy is finalized, robots become the planetary architects, carrying out the intricate and often dangerous tasks required to reshape an environment. Picture swarms of autonomous drones planting vegetation to stabilize soil, or massive construction bots building atmospheric processors to convert carbon dioxide into oxygen. These machines can work tirelessly in conditions that would be lethal to humans, making them indispensable for the long and arduous process of terraforming. Take Elon Musk's vision for Mars as an example. He envisions a future where humans not only visit the red planet, but transform it into a second home. To achieve this, robotic systems would likely lead the charge, deploying technologies to release stored carbon dioxide from the Martian soil and polar ice caps. Over time, this would thicken the atmosphere, raising temperatures and allowing liquid water to exist on the surface. It's a bold plan, and while it may take centuries to fully realize, the combination of AI and robotics makes it a tangible possibility. However, as we push the boundaries of what's possible, it's crucial to consider the ethical implications of altering another planet. Terraforming raises profound questions about our responsibility to preserve the natural state of celestial bodies, especially if they harbor microbial life or unique geological features. Should we prioritize human survival over the potential existence of extraterrestrial ecosystems? These are questions that will shape not only the future of space exploration, but also our understanding of our place in the universe. Space colonization isn't just a technical challenge, it's a moral one. As we push the boundaries of human exploration, we're faced with questions that go beyond engineering and logistics. What happens if we encounter extraterrestrial life? How do we ensure that our presence in space doesn't disrupt ecosystems that may have existed for millennia? These are the ethical dilemmas that come with the territory of becoming a multi-planetary species. One of the most pressing concerns is the potential for harm to alien environments. Imagine landing on a distant moon or planet, only to discover microbial life forms or delicate ecosystems. Our actions could inadvertently destroy what we've only just begun to understand. This is where AI and robotics play a crucial role. Advanced sensors and autonomous systems can help us study these environments without direct human interference, minimizing the risk of contamination or damage. But even with these tools, we must tread carefully, guided by a commitment to preservation over exploitation. Then there's the question of ownership. Space is often referred to as the final frontier, but who gets to claim it? The resources found on asteroids, moons, and planets, like rare metals or water, could be game changers for industries on Earth. But if only a handful of nations or corporations control these resources, it could lead to inequality on a cosmic scale. This is why international cooperation is essential. Space doesn't belong to any one country, it belongs to humanity as a whole. Establishing fair and equitable frameworks for resource use will be key to avoiding conflicts and ensuring that the benefits of space exploration are shared globally. AI and robotics can also help level the playing field. Automated systems can make resource extraction more efficient and less reliant on human labor, reducing the risk of exploitation and ensuring that operations are conducted responsibly. But even with these technologies, we need clear ethical guidelines. Who decides how these systems are used? How do we prevent them from being weaponized or misused? These are questions that require input from scientists, ethicists, policymakers, and the public. The good news is that we're already seeing progress in this area. Organizations like the United Nations have begun drafting agreements aimed at promoting peaceful and cooperative space exploration. These efforts highlight the importance of collaboration over competition. After all, the challenges we face in space are too vast for any single nation to tackle alone. By working together, we can ensure that our journey into the cosmos is not only successful, but also just. This brings us to the broader role of international collaboration in space colonization. As we look to the stars, it's clear that our greatest asset isn't just technology, it's our ability to unite as a global community. The next frontier isn't just about building colonies, it's about building a future that reflects our highest ideals. And that starts with how we approach the ethical questions that come with exploring the unknown. Space colonization isn't just the dream of one nation, it's a global mission that demands unity and collaboration. Imagine a future where countries set aside their differences and work together, pooling resources, knowledge, and technology to explore the cosmos. Artificial intelligence and robotics are playing a pivotal role in making this vision a reality. They act as universal tools, capable of standardizing systems and processes across borders, ensuring that no matter where a rover is built or a satellite is launched, it can seamlessly integrate into a shared framework. This standardization is key to fostering international cooperation, as it removes barriers and creates a common language for exploration. Take the International Space Station, for example. It's a shining testament to what humanity can achieve when we work together. Built and operated by multiple nations, the ISS has become a symbol of collaboration in space. Robots and AI systems on the station assist astronauts from different countries, performing tasks with precision and efficiency, regardless of who's in charge. This kind of multinational partnership paves the way for even more ambitious projects, like joint missions to the Moon and Mars. Imagine a mission where robotic rovers from one country analyze Martian soil, while AI systems from another country process the data and share it globally, advancing our collective understanding of the Red Planet. But it's not just about governments and space agencies. Private companies are stepping into the spotlight, bringing innovation and fresh perspectives to the table. Companies like SpaceX and Blue Origin are already working alongside national space programs, proving that the future of space colonization will be a shared effort. These partnerships between public and private entities are accelerating progress. blending the ambition of nations with the agility of private enterprise. Together, they're pushing the boundaries of what's possible, proving that when humanity unites, the stars are within reach. When it comes to the next frontier of space colonization, private companies are leading the charge in ways that were once unimaginable. SpaceX, Blue Origin, and other innovators are not just pushing the boundaries of what's possible, they're rewriting the rules of space exploration. By harnessing the power of artificial intelligence and robotics, these companies are dramatically reducing costs, increasing efficiency, and accelerating progress toward making space habitable for humans. Take SpaceX's Starship, for example. This fully reusable spacecraft isn't just a marvel of engineering, it's a game changer for the future of space travel. Designed to carry both colonists and cargo, Starship could one day transport hundreds of people to Mars or other destinations, making large-scale space colonization a tangible reality. But the real magic lies in how AI and robotics are integrated into its operations, from autonomous navigation systems to robotic arms that assemble structures in orbit. These technologies are making space missions faster, safer, and more cost-effective than ever before. The collaboration between private companies and government agencies like NASA is another key factor driving this progress. While competition fuels innovation, think of the race to develop reusable rockets. Collaboration ensures that resources and expertise are shared to achieve common goals. For instance, NASA's Artemis program, which aims to return humans to the Moon, is partnering with private firms to develop lunar landers and other critical technologies. This synergy between public and private sectors is creating a powerful ecosystem where breakthroughs in AI and robotics are rapidly advancing our capabilities in space. But what does this mean for the future of space colonization? As private companies continue to innovate, the dream of establishing self-sustaining colonies on the Moon, Mars, and beyond is becoming increasingly achievable. These efforts are not just about exploration, they're about securing humanity's future by expanding our presence into the cosmos. The combination of cutting-edge technology and bold vision is paving the way for a new era of discovery, where the stars are no longer out of reach. This momentum raises exciting questions about what comes next. How will these advancements shape the way we live and work in space? What new opportunities will emerge as we build the infrastructure for interplanetary life? The answers lie in the continued collaboration between human ingenuity and the machines that make it all possible. The future of space colonization is not just a distant dream, it's a rapidly evolving reality shaped by groundbreaking technologies and visionary ideas. One of the most exciting developments is the rise of swarm robotics, where fleets of autonomous robots work together seamlessly to perform complex tasks. Picture thousands of tiny machines, each programmed to communicate and collaborate, building habitats, mining resources, or even terraforming alien landscapes. This approach isn't just efficient, it's revolutionary, allowing us to tackle challenges that would be impossible for humans or single robots alone. At the heart of this transformation is artificial intelligence, which is becoming increasingly adept at designing and managing entire colonies. Imagine AI systems capable of analyzing planetary conditions, optimizing resource allocation, and even predicting potential risks before they arise. These systems won't just assist us, they'll empower us to create self-sustaining ecosystems on worlds we've never set foot on. It's like having an architect, engineer, and strategist all rolled into one, working tirelessly to ensure our survival and success in the cosmos. But the ambition doesn't stop at our solar system. Visionary projects like Breakthrough Starshot are pushing the boundaries of what's possible, aiming to send tiny spacecraft to neighboring star systems at a fraction of the speed of light. These missions could pave the way for interstellar travel, opening up entirely new frontiers for exploration and colonization. The role of AI here is critical, not just in designing these spacecraft, but in navigating the vast, uncharted distances of space. It's a monumental challenge, but one that could redefine humanity's place in the universe. As we look to the stars, it's worth reflecting on what this means for us as a species. Space colonization isn't just about survival or scientific discovery. It's about expanding our horizons, both literally and metaphorically. It's a testament to our ingenuity, our resilience, and our unrelenting curiosity. The challenges ahead are immense, but so are the opportunities. And with AI and robotics as our allies, the next frontier might be closer than we think. Space colonization is about so much more than just securing humanity's survival. It represents a profound leap in our collective potential, a chance to redefine what it means to be human and to expand our understanding of the universe. Imagine a future where we're no longer bound to a single planet, but instead thrive across the stars, uncovering secrets about life, existence, and the cosmos itself. This isn't just science fiction, it's a vision made possible by the incredible advancements in artificial intelligence and robotics. These technologies are the backbone of our journey, enabling us to explore, build, and sustain life in environments that were once thought impossible to conquer. Think about it. AI-powered systems can analyze vast amounts of data from distant planets, identifying resources, potential hazards, and even signs of life. Robotics, on the other hand, allows us to construct habitats, mine asteroids, and maintain infrastructure in the harshest conditions, tasks that would be too dangerous or impractical for humans alone. Together, they're not just tools, they're partners in our quest to push the boundaries of knowledge and capability. And as we venture further into the cosmos, we're not just exploring new frontiers, we're also learning more about ourselves. What does it mean to be a species that can adapt and thrive beyond Earth? How does this shift our perspective on our place in the universe? There's also a deeply philosophical dimension to this journey. Becoming a multi-planetary species challenges us to rethink our values, our connections, and our responsibilities. It reminds us that we're part of something much larger, a universe teeming with possibilities. And beyond the science and philosophy, space exploration inspires hope. It reminds us that even in the face of immense challenges, humanity has the capacity to dream big, innovate, and persevere. It's a beacon of optimism, showing us that the future is not something to fear, but something to shape. As we reflect on the role of AI and robotics in this grand endeavor, it's clear that they're not just enabling survival, they're unlocking the next chapter of human potential. From expanding our scientific horizons to inspiring generations, space colonization is a testament to what we can achieve when we dare to look beyond the horizon. And as we continue to explore, one thing is certain: the journey is just as important as the destination. As we wrap up this exploration of the next frontier, let's take a moment to reflect on the key insights that define the future of space colonization. At the heart of this monumental endeavor lies the transformative power of artificial intelligence and robotics. These technologies are not just tools, they are the architects of a new era, capable of building habitats, mining resources, and even maintaining life-sustaining systems in the harshest environments imaginable. But with such groundbreaking innovation comes a unique set of challenges, from the technical hurdles of operating in zero gravity to the ethical dilemmas of AI decision-making. Every step forward demands careful consideration and ingenuity. What's truly remarkable is how this journey transcends borders and disciplines. Space colonization isn't just the work of engineers or scientists, it's a collaborative effort that draws on expertise from fields as diverse as biology, ethics, and international law. It's a reminder that the stars belong to all of us, and reaching them will require a unified, global effort. This isn't just about technological progress, it's about humanity coming together to achieve something greater than ourselves. As you think about the possibilities we've discussed today, consider the role you might play in this unfolding story, whether it's through supporting research, advocating for ethical practices, or simply sparking conversations about the future. Every voice matters. The path to the stars is paved with challenges, but it's also filled with opportunities to redefine what it means to explore, to innovate, and to dream. So, as we look ahead, let's carry these ideas with us not just as distant possibilities, but as a call to action for the kind of future we want to build together. As we stand on the brink of this new frontier, it's worth taking a moment to reflect on how each of us can play a part in shaping the future of space exploration. Whether you're drawn to the sciences, engineering, or even the ethical and societal implications of colonizing new worlds, there's a role for everyone in this grand endeavor. What excites you most about the idea of living among the stars? Is it the thrill of discovery, the potential to solve Earth's challenges through space-based solutions, or the chance to witness humanity's greatest achievements unfold in real time? The advancements in artificial intelligence and robotics we've explored today are just the beginning. These technologies will not only build the infrastructure for space colonies, but also inspire entirely new fields of study and innovation. Imagine the possibilities. What if your career or passion could contribute to the next giant leap for humanity? Whether it's through pursuing education in STEM fields, advocating for space exploration policies, or simply sparking conversations about the future, every effort counts. So, what's your vision for how AI and robotics will shape our journey into the cosmos? Do you see them as tools for problem solving, or do you believe they'll redefine what it means to be human in a spacefaring civilization? Share your thoughts in the comments below. Let's build a vibrant community of thinkers and dreamers who are as excited about this future as we are. Together, we can turn these ideas into reality. And if this conversation has sparked your curiosity, don't stop here. Subscribe to stay updated as we dive deeper into the technologies and ideas that will define the next chapter of human exploration. The stars are waiting, let's reach for them together. The future of space colonization isn't just a dream, it's a journey we're all a part of. If you're as excited about the possibilities of AI, robotics, and the next frontier as we are, don't miss out on what's coming next. Hit that subscribe button and ring the notification bell to stay updated with the latest breakthroughs in futuristic technology and space exploration. We're just scratching the surface of what's possible, and there's so much more to uncover together. For those eager to dive deeper, check out books like The Case for Space by Robert Zubrin or documentaries like The Farthest Voyager in Space. Websites like NASA's official page and SpaceX updates are also fantastic resources to keep you informed and inspired. The stars aren't just a destination, they're a calling. Every step we take toward understanding them is a step toward unlocking the infinite potential of human ingenuity. So, what are you waiting for? The next chapter of humanity's story is being written right now, and you have a front row seat. Let's explore the cosmos together, because the future isn't just something we wait for, it's something we build, and who knows, the next great discovery could be yours. As we stand on the precipice of a new era, the dream of space colonies no longer feels like a distant fantasy, but a tangible reality within our reach. From the bustling cities of Earth to the untamed frontiers of the cosmos, we've explored how artificial intelligence and robotics are the architects of this grand vision. These technologies are not just tools, they are the bridge between our planet and the stars, transforming barren landscapes into thriving habitats and turning the impossible into the inevitable. Think about it, every step forward in AI, every advancement in robotics, brings us closer to a future where humanity isn't confined to a single world. We're not just imagining life on Mars or lunar outposts, we're actively building the systems that will sustain it. From autonomous construction, bots laying the foundations of extraterrestrial cities, to AI-driven life support systems ensuring our survival, the pieces of this cosmic puzzle are falling into place. And yet, this journey isn't just about technology, it's about us. It's about our unyielding curiosity, our drive to explore, and our ability to dream beyond the horizon. Space colonies represent more than just a new chapter in human history. They symbolize our collective ambition to reach higher, to push boundaries, and to create a legacy that stretches across the stars. So as we look to the future, let's carry with us a sense of wonder and optimism. The challenges are immense, yes, but so are the opportunities. The future isn't something that happens to us. It's something we shape with every decision, every innovation, and every step we take. To close, let's remember the words of Carl Sagan, who once said, "Somewhere, something incredible is waiting to be known." The incredible is no longer waiting. It's being built, piece by piece, by the brilliance of human ingenuity and the power of machines. The stars are calling, and together, we're answering. Thank you for joining us on this incredible journey into the future of space colonies, where artificial intelligence and robotics are paving the way for humanity's next great frontier. Your support means the world to us, and we're thrilled to have you as part of this growing community of explorers and dreamers. If you enjoyed diving into the possibilities of how AI and robotics will shape our future among the stars, don't forget to give this video a thumbs up, share it with someone who loves futuristic tech, and let us know your thoughts in the comments below. What do you think will be the biggest challenge in building space colonies, or what excites you most about the idea of living beyond Earth? We'd love to hear from you. And stay tuned, because in our next video, we're taking a closer look at how quantum computing could revolutionize everything from medicine to space travel. It's another mind-bending topic you won't want to miss. Until then, keep dreaming big and exploring the endless possibilities of what lies ahead. This is Channel Name, signing off, where the future is always within reach.
See you next time.